Hey guys, Travis Gillespie here. Today we're going to talk about real numbers. And this is a system of numbers. So let's just backtrack to when you were a kid, you were first starting to learn how to count. And maybe you could count 1, 2, 3, and maybe you're watching TV shows such as Dora or Barney, and they helped you count all the way up to 10. But these are your natural numbers, and we call them natural or counting numbers. I'm going to put a box around this because as time goes on and you become a little bit more sophisticated, maybe you're not going to watch Dora or Barney anymore, you're going to move on to something like Sesame Street. And Sesame Street, they teach you there's a whole new number in this list. And a good way to think about it is maybe you've got a cookie in your hand or a few cookies in your hand. Maybe you have 3 cookies. And after you eat all 3 cookies, you learn that, hey, you know what? You don't have any more cookies left, so you have 0 cookies in your hand. So you learn the new number in this list is 0. And we call all of our numbers in this list, which include 0, our whole number set. And maybe at this time you've learned to count beyond 10. But time goes on still, you get older, and I'm just boxing everything up here. So your whole numbers, they include the counting numbers and 0. Okay, so as you're getting older, you learn that there's more to the puzzle than just numbers that include 0 and that are greater than 0. Maybe you're in middle school now, and you're about to go on a family trip, and you learn that you live in Texas, it's a warm state, and you learn that the family you're going to visit lives in a colder state. And what you learn is that, hey, you know what, in Texas, the temperature can be greater than 0. So we have our numbers that are whole numbers still, 1, 2, 3, and so on. And you learn that the family you're going to visit lives in a state that the temperature is colder than 0. The temperature can reach 0 or it could drop below 0. So we'll say it could be -1 degrees, -2 degrees, -3 degrees, and so on. And these numbers can go below 0 in the opposite direction forever. They continue on. And we call these numbers integers. And another good way to think about integers is maybe on this trip you need to buy a coat because you don't want to be cold. And you've taken all the money that you've saved and you want to buy a coat that costs more than the money you have. So, well, if you tried to pay for it, you'd run out of money, you'd hit 0, and you've got to borrow money from a family member, or maybe you're going to take out a loan. So when you borrow money or take out loans, you go into debt. So you have minus money, or you have a negative amount of money in your hand. So now we get into the concept of negative numbers and opposites. So one cool thing here, I'm going to draw a number line. All right, and let's put these arrows on here, and I'm going to put 0 down. So we have 0, we have positive numbers, 1, we have 2, we have 3, and this arrow moving off to the right says these numbers go on forever in a positive direction. And off to the left of 0, well, we have -1, we have -2, and -3, and these numbers go off into a negative direction. And it gets us into a concept of looking at signs or symbols. Well, numbers that are less than 0, we use a minus sign, and I'm just going to put that minus sign here to indicate that these are negative numbers. And numbers that are greater than 0, we use a positive symbol. It looks like a plus sign, but this indicates that these numbers are positive. Well, what about 0 itself? Well, 0 is neither a negative number, nor is it a positive number, so we call 0 a neutral number, N-E-U-T-R-A-L. So 0 is neutral, and that gets us into the concept of opposites. Let's just go ahead and look at positive 3 here. Positive 3 is, well, it's 1, 2, 3 units away from 0 in a positive direction, while negative 3, its opposite value, is an equal distance away from 0. It is -1, -2, -3 units away from 0. So opposites say, hey, you know what? Whatever number you're looking at, the opposites are an equal and opposite distance away from the number 0. So positive 2 is 2 units away from 0, while its opposite value, -2, is an equal and opposite distance away from 0 in the negative direction. A good mental math trick here to keep in mind is as numbers move to the right of 0, they're getting greater. As numbers move to the left of 0, they're getting smaller. Let's go ahead and box this information up. Keep in mind everything, whole numbers and counting numbers, are included in the integer set. Now before we move on to looking at the next set of numbers in this list, let's go backtrack to the real number system. Real numbers are composed of two types of numbers. They're composed of rational numbers and they're composed of irrational numbers. And I'll talk about irrational numbers in just a minute. But rational numbers, they are composed of ratios or fractions. And we actually see that word within the word rational, ratio. I'm going to go and fix that I and O just so it's more clear. So rational or ratio meaning fraction. And rational numbers are any number that can be expressed as a fraction. So let's put our number line down here. And on this number line we have all of our negative numbers still. -3, -2, -1, and 0. But now we're going to look at fractions or parts of a number. So let's think of the concept of having a party. You want to have a party and you're going to have your buddies over. You're going to have pizza, maybe ice cream, sodas, cake. But you're not going to eat the entire pizza, ice cream, cake, or drink the entire soda. You're going to share it with your friends. So you're only going to have a part of it or a fraction of it. Maybe you only eat a quarter of the pizza, so 1/4 or 1/4. Or maybe you only have half of the soda, so 1/2. And then you move on to other fractions, but then you can bump into the value 1, or think of it as one whole. You have one whole of the entire pizza. And these numbers continue on forever as well. They go in the positive direction. We need to get a little bit more space here, so let's take all this information and slide it up. Move it to the side just a little bit. There we go. And well, I just said rational numbers, well, it's any number that can be expressed as a fraction. So I'm just going to put two variables down, x over y. Now there's one trick here, one key piece of information. The number that's in the denominator, in this case I have a y, I cannot replace y with the number 0. So it's any number that can be expressed as a fraction as long as the value in the denominator is not 0. Well, rational numbers, what they end up doing is they create numbers that have decimals, and the decimals are either considered to be repeating decimals, such as, well, 0.66666 or 0.33333. I'm just going to put that below 0.3, and I'm going to put a bar, an over bar, over the 3 to state that, hey, 3 continues on forever. It's a repeating decimal. Or they create decimals that are terminating, such as 0.5 or 0.1234. And in fact, if we look at that number line, I said 1/4 earlier, so a good example here would be 0.25, and the decimal terminates after 5 here. So let's go ahead and box this information up, but I want you to keep in mind, as I'm boxing up every single type of number, integers, whole numbers, counting numbers, well, all of these numbers in this set can be considered to be rational numbers and real numbers. Well, there's another set of numbers that are disconnected from rational numbers, and they are numbers that are irrational. Well, what could irrational numbers be? Well, let's remember that rational numbers, they can be any number expressed as a fraction that create repeating decimals or terminating decimals. Therefore, irrational numbers have to be numbers that have decimals that are non-repeating or non-terminating. Well, a few to look at here would be the number pi, You probably know this value in school as the number 3.14, but this number, it continues on forever. It's non-repeating and non-terminating. A couple of others to think about, which we'll talk about in the future, are the square root of 2 and the square root of 10. So these are all irrational numbers. They're disconnected from the set of rational numbers. However, both irrational and rational numbers are a part of the larger set of real numbers, which we're going to box up here. So let's go ahead and box this up. And then I want to talk about one last system of numbers. So within the real numbers system, we have rational and irrational numbers. And disconnected from our real numbers set, we have numbers that are not real. So not real numbers here. And we're only going to look at one right now. And we're going to look at square roots this time, but square roots with negative numbers inside. So the square root of, I don't know, let's just say negative 17. And we'll look at this in the future, but just know that there is not a single negative number that can have a real square root. So therefore, we call these not real. Cool, guys. I'll see you in the next video.